Hi guys, we're going to be discussing rational functions and their asymptotes and end behavior um, in this video. So we're going to start out, we're going to look at what happens, what is the end behavior, or what is the behavior as x approaches a vertical asymptote. So we're going to use the same limit notation right here, and we read that as what's over here in this box, the limit of f of x as x approaches a with this little negative sign. What that means is a, but as we approach a, but from the left of a little bit less than a, so think a minus a little bit. So as the graph is approaching a from the left, so we're coming towards a, but the little negative sign means from the left, what's happening to the graph? So the vertical asymptote is a guide for our graph, and the graph is never going to cross the vertical asymptote, but it's going to approach it, and as it comes towards that, it's kind of like a wall. You have this wall here, and the graph is either going to go up to positive infinity or it has to go down to negative infinity. So if you look at this graph in this example, as x approaches a from the left, it's going up, so it's going to be approaching positive infinity. And anytime that you're using, you're trying to determine what's happening near a vertical asymptote, your answer to the limit notation over here is going to be either positive infinity or negative infinity. And if we look at the second piece right here, this says the limit of f of x as x approaches a with a little plus sign. It's like in an exponent where the exponent normally would be, means we're coming towards a from the right side. So this is the right side of a. So as x is getting closer to a little bit more than a, what's going on with the graph? So as we approach that asymptote from this side, in this particular example, the y-coordinates are going towards negative infinity. All right, so a rational function is undefined when the denominator, what can't you have in the denominator? Think about it. When the denominator is equal to 0. And so to find vertical asymptotes, we're going to determine where the function is undefined. X cannot be that value that makes the function equal 0. And you're going to have one of two types of discontinuities, because it won't be continuous there, because you can't have that value of x in the function. So there won't be a y-coordinate for that value of x, which means it's going to be discontinuous. You're either going to have a vertical asymptote or you're going to have something called a removable discontinuity. So if there's no identical factor in the numerator, you will have a vertical asymptote at that value of x. If there is an identical factor in the numerator as the denominator, there will be what's called a removable discontinuity. I will show you what a removable discontinuity is shortly. But basically what it is one tiny little missing point in the graph, or like a hole in the graph, instead of a whole line that causes the graph to go to infinity or negative infinity. Okay, so let's do an example. So we're looking for factors that are the same in the top and the same in the bottom. We're looking for where the denominator would equal 0. So in this case, if you look at this, the denominator equals 0 when x is -2 or when x equals -3. Now, are there any matching factors in the numerator? Well, one of the things you're going to need to do for a lot of these problems, if it's not already done, is factor, if it's factorable. So in the numerator, it's a difference of squares. We'll factor into x plus 1 over x minus 1 times x plus 1. And there, if you look at this thing written out here, there are no matching factors in the numerator as there are in the with factors in the denominator. So that means that at these two values of x that make the denominator equal 0, we will have vertical asymptotes in the graph. So my vertical asymptotes, any vertical line, is going to have the form x equals that value of x. So x equals -2 and x equals -3 are my two vertical asymptotes. So now what we're going to do is we're going to figure out what happens as you approach -2. Is the graph going to go towards positive infinity or negative infinity? So we have vertical asymptotes. Here's a graph that has vertical asymptotes at -2 and at -3. And we're looking at what's happening as you approach -2. And in this top part, bear with me here, we're going to look at what happens to the graph of f of x, what's happening to y as x approaches -2 from the left, because that's a little negative sign. So this is the left side of -2. This is the right side, so this would be -2 with a little plus sign in it. So is the graph going towards positive infinity as you approach -2 from the left, or is it going towards negative infinity? That's what we need to determine. So let's do that. So it's, again, either going to go to positive infinity or negative infinity. So what we can do is pick a value that is close to, choose a value of x. That's close to -2, but less than -2. Now, if you think about this, the negative can cause errors here. So let me show you what I mean. So here, oops, how did that get erased? All right, so we have -2 right here, -3. Oh, I guess I erased those asymptotes. That's how. All right, so a point on the, so if I go to the left of -2, like really close to -2, but on the left side, that's going to be even more negative. So let's pick a value of x like -2.1. So we choose a value of x that's close, really close to -2 on the left side. You don't want to go like to -3. That's too far away. You want to go close. So let's pick a value of x like x equals -2.1. And what we're going to do with that x coordinate is we're going to plug it into the function f of x, and we're going to decide if it makes everything negative or everything positive. So here's how you do it. We're going to look at, these are our factors here. If I put in -2.1 for x, and eventually I want you to be able to do this, a majority of it in your head. Let's see what I mean. If I put in -2.1 for x and evaluate this, all I'm looking for, I don't need to know the exact number. I just need to know if this whole thing would be positive or negative. So if you look at this factor right here, oops, is not positive. -2.1 minus 1 would be a negative. And then we're going to multiply that by -2.1 plus 1, which is still a negative. So you have a negative times a negative in the top. -2.1 plus 2, still negative. And -2.1 plus 3 is a positive. So in the denominator, we have a negative times a positive. So we end up with a negative times a negative divided by a negative times a positive. With 3 negatives, if you have an odd number of negative factors, it makes the whole thing negative. So this is going to approach negative infinity. So you don't need to actually plug it in. What you want to do is just be thinking about, like, if I did plug in -2.1 here, that x minus 1 would be a negative, and then I'd have this right here would be another negative, and then this one, -2.1 plus 2 is a negative, and then we have a positive. A negative times a negative divided by a negative times a positive is going to result in a negative. All right, so now we're going to do the same thing, but we're going to look at what happens. Oops, I'm going the wrong direction. So we know right now that the graph is going to approach negative infinity as we approach -2, as we approach that asymptote from the left. Now we're going to see if it's going to positive infinity or negative infinity on this side of -2. So like -1.9 would be a good choice. So let's do that. And we're going to plug it in and determine if we're going to get a positive or a negative result. So putting in -1.9 into this is my f of x. So I'm trying to figure out, is f of x positive or negative? All right, so putting in -1.9, positive or negative? Think it in your head. That would be a negative. And then putting in -1.9 plus 1, we get another negative. Down here, -1.9 plus 2 is positive, and -1.9 plus 3 is also a positive. So now we have a negative times a negative, which is a positive, divided by a positive. So we end up with positive infinity. So as x approaches -2 from the right, it's going towards positive infinity. Now we need to do the exact same thing, but for -3. So a good value of x from the left as x approaches -3 from the left would be like -3.1. We're going to let x equal -3.1. So you guys should plug that in and determine if you're going to get a positive or a negative result, and then do the same thing for a value of x close to -3 but on the right side, like let x be -2.9, and determine if you get a positive or negative, and then we'll decide if it's going to positive or negative infinity. So if you plug in -3.1 into f of x, all right, so when you plugged in -3.1, you end up here with, we have you, a second, no, it's won't let me write, come on computer. You end up with a negative. This first factor would be a negative, because if you put in -3.1 here, -1, you get a negative, and another negative when you put it into this factor, and another negative here, and another negative here. 4 negatives, that's an even number of negatives. A negative times a negative in the top makes it positive, and a negative in the times another negative in the denominator makes it positive. So that's going to be approaching positive infinity as you approach -3 from the left. And then when you put in the -2.9, you end up with a negative times a negative. This would be -2.9 minus 1, -2.9 plus 1. Both of those are negative, and that one would be positive. So we have a negative times a negative divided by a negative times a positive. You end up with a negative infinity as you approach 3 from the right side. So on my graph, it would look something like this. It was positive infinity. I can't remember. Positive infinity as you approach -3 from the left, and the negative on the other side. So it was positive. Whoa. Hang on. Positive infinity on this side, and on the other side is going towards negative infinity. So if you just take a look at this graph, this is the graph of the function. If you're going to put it in to your calculator, you need to make sure you put the numerator, the entire numerator, in parentheses, x squared minus 1 in parentheses, and then the whole denominator also has to get put into parentheses. So I needed a double parenthesis here for the denominator, and then each factor had to be also put in parentheses. And then I had to set a window. I had to find the window that worked here, and I used -5 to 1 because I knew I was looking for asymptotes at -2 and -3, and then -50 to 25 in the other direction. And you can see that indeed you do have vertical asymptote